So here we have geometric sequences and really finding the summation. So like we had for the arithmetic sequence, that this is finding the summation for a geometric sequence. And so for this one, there's this one main formula that you want to know. So it really states that to find the sum, that is equal to a1 times 1 minus r to the power of n divided by 1 minus r. Now this is a formula that you use to find the sum for a geometric sequence. So we have this formula here, but what's important to understand is that this formula is only applicable for geometric sequences that are finite. And so when I'm saying they're finite, right? Finite geometric sequences, that obviously means that they're not infinite, right? They have a definite stop. They have a defined stop. So these sequences are going to stop to a certain value. For instance, if you had a ratio that was over 1, you had a common ratio of 2, and then you have that ratio going infinitely, then obviously your overall summation is going to be infinity, right? Because it's not going to stop, and that value is just going to exponentially increase. So this formula is specifically for those that have that defined range mentioned. So that's why they're called finite geometric sequences. So that's the formula that you want to know. Now I may give an example here. So if you have something like find sum of the following. So we have this n is equal to 1, and this could be 7. And then we have 2 to the power of n minus 1. Now this symbol here, again, just know that symbol, you will see this often. This symbol is, it's known as summation, right? It just indicates that you're finding the sum, or the summation. So that's the symbol for that. And so looking at this, and we know what our given function is. So what this really indicates is that we're finding the sum when you have n is equal to 1, up to the point when you have n is equal to 7. So this is the minimum value for n, this is the maximum value for n. And really, at all those points, at all those n values, you're really putting those values in for n here and determining those outputs, and then adding those outputs. You're doing the summation of those outputs to determine the overall outcome of this problem here. So it's just saying that n is equal to 1 and n is equal to 7, and all the n's between those from 1 to 7, you're putting those into this function, and then you're adding each individual value. So that's what it means. Now clearly, if you have something like this, if you have 2 to the power of anything, right, that indicates that as you, for instance, say n is 4, I don't know, n is 4, that would indicate that if n is 4, then 2 to the power of 4 minus 1, that's 2 to the power of 3, is 8, right? And if you say n is 5, then 5 minus 1 is 4, 2 to the power of 4 is 16. And you see that there's that common ratio, right? There's that common ratio of 16 divided by 2, that is 16 divided by 8, 16 divided by 8 is 2, and so that is your common ratio. And so really, when we have this exponent, right, the base of the exponent, right, the base, in this case this is the base, here the base, which in this case is 2, is your common ratio. So we know that r, in this case r, which is known as the common ratio, is 2, because the base of this overall exponential function, you could say, is 2. So our common ratio is 2. So we know what our value for r is. Now to find a1, we want to know what the first term is, and we know that n is equal to 1 is where it starts from. Now this could have been n is equal to 0, then we would have to put 0 in, but obviously n is starting from 1, therefore we're plugging 1 here. So 1 minus 1 is 0, and 2 to the power of 0, anything to the power of 0 is 1. So we know that our first term here is 1. Right, so we know this, we know r, and we know a1. Now we have this formula up here, right, and we know what a1 is, and we know what r is, so we can now plug in our values, really. So to find the sum, we would do a1, which is 1, times 1 minus r, which in this case is 2 to the power of n, right? And obviously n here is the number of terms you're looking at, right? So here we have 1, 2, 3, 4, 5, 6, 7. We're looking at 7 terms, therefore it's 1 minus 2 to the power of 7. So again, this n over here, you could see that's just the number of terms that we're going, because again, it's a finite sequence, right? So there is going to be that defined number of terms. So it's 1 times 1 minus r, which in this case is t to the power of 7, right? Divided by 1 minus r being 2. So that's what the sum is really equal to. And now you will be surprised that the denominator is a negative value, but it doesn't really matter because the value in the numerator will also be negative. So that's going to give you a positive value overall, and in this case that is 127. And so to verify your work, you could plug in 1 here. I know that's 1, and then 2 would be 2 to the power of 1 would be 2, and then 3 would be 4, and just going on till 7, and then adding those values should give you a sum of 127. So that's just the basic labeling here. This being the summation, n is equal to 1 is your first value that you're looking all the way till your 7th value, where again n or 7 is your maximum value that you're looking at. This is your function, your base here. If it's an exponential function, that should be the common ratio. In this case, it was 2, and then you're using this main formula here, a1 times 1 minus r to the power of n, all divided by 1 minus r. So that's the first problem that I want to go over here, and I just did. So there's another problem I have. Again, it's just going to utilize that same concept. So the second problem here states that you're given the following, that S12, you could say S12, so you have something like that, again the summation sign, and then you have I is equal to 1, 4, and then you have 0.3, and then you have I minus 3 here. So now we look at this, right? And we want to find the sum. And again, this is a finite geometric sequence because we have I is equal to 1 and we have 12, right? The minimum and the maximum values. So looking at this now, we want to find the sum. So we know our formula is this, right? And before we want to put anything in our formula, right, we want to know what our common ratio is. And so to find the R, or the common ratio, we really know what the common ratio is based off of this. And again, the reason is we know the base, because although we know that there's a 4 here, it doesn't really matter, because overall when you multiply each value by 4, whatever you get here, the overall effect still states that the common ratio is the base of that exponential function. So in this case, again, your common ratio is 0.3. So you know your common ratio is 0.3, and then your first term is something that you want to know. To find the first term, you're really plugging 1 here, right? And that makes sense because that's your first term, right? I is equal to 1 is where your range is starting from. That's the first value that you're going to have, right? A1. So we plug 1 here. We see that's 4, and then we have 0.3 to the power of 1 minus 3. That's negative 2. And so really 0.3 is 3/10. And so when we have that to a negative power, raised to a negative power, really that means that it's 10 over 3, right? We do its reciprocal to the power of 2. So it becomes positive now, right? And so 4 times 100 over 9, right? That's just 400 divided by 9. And so if you value that further, 400 divided by 9, that should give you 44.44, something like that. You can round that. So now you know your overall values that you require. You know your common ratio and you know your first term. So now what you're really doing is you're finding the 12th term. So S12 is equal to 44.44 times 1 minus r, in this case 0.3, to the power of 12. Right, so you have this, and you're dividing all of that. You're dividing all of that by 1 minus r. Again, that's 0.3. And so if you further evaluate this, right? If you further evaluate this, you should see that S12, right, is 63.5. 63.5. Sorry if you can't see that. That's just 63.5. So your sum of the first 12 terms for this particular geometric sequence is 63.5. So again, that's just the overview of finding the sum of a geometric sequence. So thanks for watching.